How to cause this problem? I mean, this as we just explained, there's a short circuit to happen in this topology. Now, so this very curious is at the beginning the NVR was trying to put it in DC24 output. Now it's DC48, and then because this is a shared grounding, so then we checked with the provider for the PoE switch, and we found out that it's a negative devices, so negative 48. And the NVR is obviously positive 48. So this is a very, this is a clue that caused this problem. Okay, um, so first we should understand that what is positive devices and negative devices. Why there's such things? Okay. First, a normal civil usage devices it's a positive devices, right? So you see that if we have a DC power system, provide a DC power to the civil devices, we have a positive 48 and negative with GND. Those are very common device, right? So for example, if you have this kind of devices, so let's simplify the topology of the inside of the device. It's like this is the enclosure of your device, and you have outside you can see the label with the DC48 and the GND. Oh, okay, so inside you have an input, the EMI filtering and this kind of circuit, whatever. Then the 48 and 48 DC connect to the inside of 48 DC and then GND to GND. So inside it has a lot of whatever converter change DC48 to DC48 to 12 volts to 5 volts, whatever, it will make a lot of change. But anyway, this is a positive device, right? But we should know is in the world there's another kind of devices. It's a negative devices. It's negative DC48 devices, which this kind of device is designed for telecom purpose. So in telecoms industrial, it's very normal that we have a negative 48 VDC devices, which looks like this, and DC power provide a negative DC48 to the telecom devices, and the GND is positive, so it's work like this way. But we should be very, very careful is not all the devices labeled very clearly about this part. I mean, this time is what we saw is our PoE switch is a negative device, but it's not labeled as a negative device. So for the enclosure itself, outside is still like a 48 VDC GND, sometimes 55 VDC, okay? Because for example, if the PoE switch support PoE++, then it will go with 55 or something. Whatever is same, okay? But you need to understand the inside is really not the positive device, it's negative. So after EMI filtering and this kind of circuit, then you go with like the positive VDC connect to the PGND or we call it RTE, whatever. Then the GND connect the negative, the negative 48 VDC. It play like this way. Then connect to internal circuit. Why? Because you see that the most of the providers such as Huawei, Cisco, and HSBC, this kind of typical telecom devices providers. Most of the devices they use is not designed for the civil usage, not for CCTV, video surveillance, this kind of scenarios. It's really designed for telecom scenarios. So they have to guarantee that their devices can work with the whole telecom system. For example, a telecom system, a typical design is there's a rectifier, the rectifier output with a negative 48 VDC, and so to guarantee the whole system work as a negative 48 VDC, so they designed the things like this. But there's other parts. It's very other devices very clearly labeled like this way. I mean, this is very obvious negative devices, right? Negative 48 VDC and GND, let's say IT same. Then GND connector inside is the PGND RT, and the negative 48 is negative 48. But it's same, whatever they label, but these two devices design is same. because if you consider the PE connect to, the PE GND connect to the PE of the case will be kind of like a positive, right? Inside the circuit is negative. And this is the biggest problem that cause short circuit in this DC UPS scenario, okay?